What is going on? Okay, in this integral, we're going to evaluate the integral of x arctan 7x. It's a little bit tougher than the other ones. Let's take a look at why. So it might be tempting to try and use substitution for this one, but it's not going to work. If you pick u to be 7x, you're going to get the derivative of that is equal to 7dx, and you're not really going to be able to sub in anything. It's just going to be just as hard. So what we're going to have to do is integration by parts. It's tempting to try and let u equal x, the thing you're going to derive, make that equal to x, so that the derivative of that, it gets simpler, turns into just dx. But that's not going to work, because then we would have to integrate arctan 7x, which would be a real pain. Okay, we don't have any easy way to do that. So we're going to have to do it the opposite way. We do, however, know the derivative of arctan of 7x. So let's try that. That means we're going to have to integrate x, and that's going to turn into x squared over 2. Generally, we don't want to do that. We don't want to pick things to integrate that makes it harder. Okay, so a higher power of x would be considered a harder thing to integrate. But in this case, we're kind of forced. So that's what we're going to do. So let's do it. We set u equal to arctan 7x. We set dv equal to x dx. This is the step we're integrating. This is the step we're deriving. We derive du equals, and then the derivative of this stuff is 7 over 1 plus 7x squared. Where does the 7 come from? That's chain rule. When we take the derivative of this, it's 1 over 7x squared times the derivative of the inside stuff, which is 7. So that's why we get the 7 here. The integral of x is, simply you should know this one, it's just x squared over 2. So no problems there. Now, using the formula from integration by parts, it's going to be the integral of this thing here becomes uv minus the integral of v du. If we put that all together, that's where this term comes from here. This should be uv, and indeed arctan 7x times x squared over 2. That's where that puppy comes from, minus the integral of v du. I just factored in some constants. This should be v is x squared over 2. That's where the 2 comes from there. Du is 7 over all this junk here. So that's where the 7 comes from, and 1 plus 49x squared is this same thing, 1 plus 7x squared. So that's where that part comes from. Okay, now is kind of the interesting part. If you look at this integral here, there's not really, like, I tried to use substitution at first, setting u equal to 1 plus 49x squared. The problem is, and you should do this, you should try and do that. If you set that to be your u, then when you take du, you're going to get a term of x there, because you're going to get 49 times 2 times x dx. It's going to make that impossible to sub out all the x's entirely. You're going to always have some x's in there. Or if you do some weird algebra, you're going to get something that's still equally as hard to integrate. So that's not the way to do this one. You're not going to use substitution. Integration by parts isn't going to work on this either. We have nothing really to integrate that's going to get simpler. So that's out. And you haven't even learned any other methods yet. You've got trigonometric substitution, and you've got partial fractions. Partial fractions doesn't work either because you can't factor the bottom. So, we're kind of out of options here. So whenever this happens, don't fret. What you're going to end up doing is, remember, you only have those 4 techniques for integration. So if it's not one of those 4, it's going to have to be algebra. You're going to have to do some algebra on this and turn it into something different that's a little easier to manage. And that's what we do in this case. So this is just polynomial division, right? We're just dividing one polynomial by another polynomial. We want to know, and this is the same with every fraction, the result of a fraction is the number of times the denominator goes into the numerator. So let's see. Under here, I have the polynomial division. Okay, and my face is covering the result, the answer here, but it's very easy. It's just negative 1 over 49. Anyway, so when we do this polynomial division, we're doing x over this. We want to know how many times does 1 plus 49x squared go into x. So that's why it's set up here, 1 plus 49x squared. And I set it up 49x squared plus 1 because when we do polynomial division, we just generally put the highest power of x out front and then you go down. So that's the only reason I switched it. And then here, this is the x squared. So we ask, what do we have to multiply this term by so that this first highest power of x matches the first thing here? And the answer is 1 over 49. Because when we multiply this whole statement by 1 over 49, the x's match here, right? So this times 1 over 49 gives me this statement right here, x squared plus 1 over 49. Now we take the difference of these two, so I go the top thing minus the bottom thing. And the result, and this is the number that's hidden by my gorgeous face right now, the result is minus 1 over 49, of course, right? 0 minus this is negative 1 over 49, and that minus that is 0. So It's just negative 1 over 49. So this goes into this. How many times? It goes 1/49 plus negative 1 over 49. That's the thing missing of these. Sounds weird, but negative 1 over 49 like over this. Okay, so that's what it is. So that's what we're going to see here in this next line here. So this goes into this how many times? It goes 1 over 49 times minus 1 over this number here. 1 over 49 times that number there. So that's the result. So I didn't do any integration here. All I did is I did this polynomial division to split it up excuse me, into two more manageable fractions. Okay, we can integrate 1 over 49, that's no problem. We can also integrate this thing here because this looks a lot like an arctan in here. So let's see what we can piece together. The next step, remember, integrals split over sums and differences. So if I have a sum or difference of things in here that I'm taking the integral of, I can take the integral of each individual component. And it's going to be the same thing. So I get integral of 1 over 49 dx, because that's the first thing, minus the integral of all of this stuff. Where the heck are all these numbers coming from, these constants? Well, there's a 7 out here, and that has to get multiplied in. There's a 2 out there, that has to get multiplied in. And there's a 49 that already exists there, so that 49 is there. And remember, you always take, well, you don't always do it, but you can always do it. You can always take the constants out of your integration. So I get this guy here. I'm left with taking the integral of 1 over 49x squared plus 1. Okay, so these ones, let's do these puppies. Here we get 7 over 2 times 49. The 7 cancels with the 49, leaving just a 7 on the bottom. Times 2 is where the 14 comes from. Okay, and then it's just the integral of dx. The integral of dx is just x. X to the 1 divided by 1, which is just x. So that's where we get minus x over 14. Now for here, again, this 7 is going to cancel with the 7 from the 49, leaving 1 7 down there. 2 times 7 is 14, so we have 1 over 14. That's where that comes from now. Okay, this one. So what does this look like? This looks like the derivative of arctan 7x. Okay, so that's why we see arctan 7x here. But remember, if I take the derivative of arctan 7x, it's going to be arctan 7x. Sorry, if I take the derivative of arctan 7x, you're going to get 1 over 7x all squared plus 1 times the derivative of 7x, which is times 7. So the antiderivative needs to have a divided by 7 to take care of that extra 7 that we would multiply by. That's where this extra 7 comes from. It comes from the fact that the antiderivative of this needs that 7. Okay, and then there's your result. So that's kind of a tricky one. I've seen some questions with an x squared here times this. That's actually easier because you end up being able to use substitution here, which is more common. This one you have to use this weird trick. So yeah, don't be freaked out if you get integrations that look like none of the methods work. That pretty much means in every case you're going to have to do some algebra to solve the problem and then get it back down to one of the techniques you already know. So hopefully that helps. Keep asking me questions. I love it when you guys do that. I love helping you guys out. So yeah, we'll talk to you next time. Pieces.